Hello everybody, good afternoon. My name is Jigar. I've been working with Microsoft from close to 6 years now. For the major portion of my career, I worked in the Office Interoperability Group. This is the group where we make sure that protocol documentation is released out on MSDN for you guys. We also work on protocol test suites, tests and tools. An example of that would be like Exchange RPC test suite, which we are going to talk about today. We also work with customers and partners very closely, just through an event just like this, Plugfest, or through IO Lab, where we work with customers on one-on-one basis. Um, the objective of the talk today is to give you detailed information about the RPC Exchange test suites that we have. I also want to tell you why you may want to use it, why you may be interested in using it. Um, I also want to give you enough information so you can do installation, configuration, and deployment of these test suites in the environment at the event over here, and even after you go back to your offices, you should be able to do the deployment of the test suite. At the same time, we also want to learn what tools you think we should develop in order to help you accelerate the process of development against Microsoft Exchange. So if you have any suggestions, just let us know. We would be glad to know that. So before I dive in, I just want to know how many of you have used RPC protocols or are using it to do processing of messages? Okay. All right, thanks. Okay, so let's dive in. Here is the agenda. I'll give you an overview of the test suite design and our development process. Then I'll tell you how to use the test suites. Then after that, we'll dig a little bit deeper into how to do debugging, troubleshooting, and what are the test logs which are available for analysis. Then I'll do a quick demo where I'll take I'll take an environment where I'll have client and server. We'll do the installation during the demo for the test suites. We'll do the configuration, and then we'll go ahead and pick some test cases to run them. I just want to show you how easy it is to run and configure these test suites. After the demo, we'll go into details about the test suite implementation. This will be helpful to you in case if you have your own server implementation for these RPC protocols. You may need to do some modification to the test suite, and we'll cover information about that in this section. And at the end, we'll go through the Q&A. But while I'm going through all these slides, if you feel you have any question, just raise your hand and we'll go through your question. So far we have seen three different class of customers or companies which are interested in protocols and which are doing analysis or implementation of these protocols. The first is those who are doing the client-side implementation of the protocol. Over here, the companies are basically developing a rich client which will communicate with the server, and by understanding all the protocol messages, their goal is to develop features like mailbox or address book or task. So that's the first kind of customers. Second is man in the middle. This is a very interesting scenario where companies develop software or appliances which will sit on the network, which will be between client and server. Their goal is to monitor all the traffic and in some scenarios do acceleration or optimization of the scenarios in order to increase the speed. So that's also, in that case also, you'll have to understand what protocol messages mean. And the third kind of category is server implementation, where companies will be having their own server-side implementation of the protocol. They would be ultimately replacing Exchange with their own product. So we'll see that out of these categories, you'll see if you are the man in the middle or you are server replacement company, then you'll find this test suites very helpful to you in order to test your own implementation of the protocols. So here are some potential uses of our test suites. Say for example, you are a man in the middle. you have done your optimization logic, and you're optimizing some scenario basically for the protocol. Now, in that case, after doing your optimization implementation, you'll need something on the client side that generates some request, which then you will do the optimization for, and then return the responses back to the client. Now, you can use our test suites to generate all this request. It will generate all possible traffic for each and every protocol, and send the traffic through you to the server. You will do some optimization on that traffic, and if you see in that case that some test cases are failing, you can safely assume that you are doing something wrong in the optimization, which is not according to the protocol. So test suite will be helpful to you in that case. Say, for example, you are a server replacement company and you are developing your own exchange, like you are replacing exchange with your own server. In that case also, you will need something on the client side that will send you requests for, for that particular protocol, and in the whatever response you send it to the client, it should it should validate that response and make sure that it is according to the protocol. So that's exactly what our test suite does. So in that case also, test suites will be helpful. Here are some other use cases where we have seen companies use our test suite and they find it helpful. So let me give you some overview of the entire development process for the test suite. Even before we start developing the test suite, we need to have the open specification itself. So first of all, we start developing the open specification. Both product group and user assistance group work together in order to create the open specification. Once we have open specification ready, that's when we kick off the process to test the documentation, to test the open specification itself. It's very interesting that we actually test the documentation. Very few companies do that, but so once we start testing the open specification, that's when we actually start developing the test suite. So when we develop the test suite, we actually start in the clean room environment. What I mean by that is the actual developer of the test suite do not have source code access. So in this case, they won't have access to the Exchange server source code. The reason we do that is because we want to make sure that test suite developers do not assume anything about the product. If they don't have access to the source code, they cannot. So they are in the environment where all they have is the access to the open specification. So by that, we make sure that we are almost in the same situation as any other third party who is doing implementation of the protocol just by reading through the technical document or open specification. So the goal here is to simulate the protocol implementation and generate a synthetic client which will generate the request messages for the protocol and then validate the responses sent by the server. So once we have the test suite ready, we test it against our own Microsoft implementation of the protocol, which in this case is Exchange server. We test the test suites against Exchange server. Then we deploy the test suites internally, run them multiple times in order to make sure that the results are consistent. We generate the supporting documentation for the test suite, and then at the end we release these test suites to the third parties, like out to the public. So as you can see, there is significant amount of work that goes behind the test suite before we can actually release them. So here I'll just dig a little bit deeper into how we actually develop the test suite. So somebody will actually go through the open specification line by line, go through entire document and read everything in order to do accuracy and ambiguity review. They will just make sure that information in the documentation is not ambiguous, it's not confusing, so that end user can actually understand it. Then we start the simulation process for the implementation of protocol. So the open specification is nothing but a set of English statements, right? Now, as Andrew mentioned in his talk, that some of these statements are contains keywords like must, may, and should. We call them normative statement. So we extract these normative statements and call them requirements. Once we have list of all the requirements extracted from the technical document, we go through the exercise of making sure if the requirement can be converted into a test case. If it can be, then we'll write the source code for that test case, and we'll end up with bunch of test cases. So in short, requirements become test cases in our test suite, and group of test cases which are doing similar kind of operations, they are grouped into scenario. Scenario is nothing but a logical representation of similar kind of test cases. So here is a very high level overview of the test suite design. Test suites, as I said, consist of a bunch of test cases. They are scenario based. So you will see we have defined some scenarios in each and every test suite. So test suite may use two adapters. We use adapter in order to make sure that our test suites are pluggable, they are easily modifiable. So one is the protocol adapter, another is the SUT adapter. SUT stands for system under test, which is also called server. So the work of protocol adapter is to generate and receive the messages about the protocol that's being tested. It also creates and maintains the connection with the server. These protocol adapters are less likely to be replaced. Even if you have your own protocol implementation on the server side, this protocol adapter will stay like it is. So you won't need to replace it in most cases. It is written in .NET. We use C# as a language to write the protocol adapter. The next is the SUT adapter. SUT adapter is used to query or configure the server when we are running the test cases. So in some scenarios, we'll see an example later, but in some scenarios, we have to interact with the server in order to do some configuration or query while we are running the test cases, and at that time, SUT adapter will work there. Now, if you have your own implementation of the protocol on the server side, then you will mostly end up modifying the implementation of SUT control adapter. So this is likely to be replaced if you have your own server. Our implementation of SUT adapter is done in PowerShell because Exchange has very rich support for PowerShell for doing all the operations. So we have used PowerShell in order to implement SUT adapter. There is a lot more detail about SUT adapter later. So right now I just want to tell you that test suite may contain protocol adapter and SUT adapter. So here is a real example of a test suite, comparing it with Outlook, what you may do in Outlook and how it relates with the test suite. So say for example you are creating a message with an attachment. At that time, Outlook will send a ROP request, ROP create attachment request, which is covered in OXE MSG protocol. And in the whatever response server sends back, Outlook will parse that and handle that one. So exactly same request is sent by our OXE MSG test suite as well. The test case which is highlighted here will also send a request ROP create attachment, and it will make sure that whatever response server sends back, it is according to the protocol specification. So so like this, test suites are actually a synthetic client. They will work as a client. They will send requests to the server, and in return, whatever response your test suites receive, they will make sure that they are according to the protocol specification. The good thing about test suites is you have the source code available. So if you want to modify some test cases according to your own requirement, you can do that. Also, it is, as we'll see later, it is very easy to do customization on the test suite. So that's a good thing as well. And they are, just because they are test suite, of course, they are automatable. So you don't need any user interaction in order to run them. You can use them as a BBT or full test. You can do full test pass as well. So here is the list of 10 protocols for which we have test suite available over here at the event, and even after the event, they will be made available to you, all you guys. So in summary, what are test suites? Test suites are a set of automated test cases which are created in order to do protocol validation. Um, they are they are originally developed to test against Microsoft implementation, but they are flexible enough to run against your own implementation of protocol as well. We use them internally to do backward and forward compatibility testing. So we would run them against Exchange 2007, and we would also run the same test suite against Exchange 2010 in order to make sure that we have not broken any protocol scenario between those two versions. There is 1:1 relationship between the protocol and the test suite. So you'll see that each protocol has one test suite, and each test suite has a focus of testing only one protocol. Um, so test suites are developed with flexibility in mind from the beginning. So you will be able to very easily modify the test suites and adapt to your own environment. They are used to test different scenarios. Also, they are, as I said, when we develop the test suite, we begin in a clean room environment. So all we refer is the open specification. So they are entirely based off of the open specification. They are very simple to understand, very easy to understand. And availability of the test suite is over here at the event. All your offices are configured to run all these 10 test suites. You'll be able to install and configure them and run all the test cases. And also, if you want access to them after the event, just let us know and we will send an invite to you to download this test suite so that you can play with them at your own offices in your environment. So, any question so far? No? Good. So, now I'll tell you about how to use the test suite. In this section, I'll cover the test environment topology. I'll give you an introduction to the folder structure about how the test suite package is organized. I'll give you information about how to install and configure server, and as well as on the client side what kind of configuration is required, how to do that. And after that, I'll tell you how to run the test cases. So this is the test environment topology. All the test suite at least contains two machines, one being the client and one being the server. As you can see here on the server side, we have installed Exchange Server 2010 SP1 on top of Windows Server 2008 R2. On the client side, we have installed Windows 7 SP1 and Visual Studio 2010 because all these test suites are created with through Visual Studio. So we need that in order to run the test suites. Now, other three things are the dependency of the test suite. So the first one there is the protocol test framework. This is a common library that all our test suite refers to. No matter what test suite is coming from what product family, even our SharePoint test suite or Windows test suite also uses the same protocol test framework. It's a common .NET library that we used across all our test suite in order to, it provides functionality like reading from the configuration file or writing log files. So common functionality is packed into this library. So we need that on the client machine. It's a dependency. Then we also need Spec Explorer, which is a dependency for those test suites which are designed as a model-based testing. So some of our test suites are uses the model-based testing approach. So for that we require Spec Explorer. And the last one is the network monitor. You know, if you want to do some network capture when you are running the test suite, that's only when you require network monitor. If you don't want to do any network capture, then it's not actually required to run the test suite. But if you want to capture the traffic, then it will be required. Now, as I said, our test suites are flexible enough. So in case if you have your own server implementation, then you should be able to replace our SUT, our exchange with your own machine and configure the test suite so that requests are sent to your server instead of exchange server. So that's also possible. We'll see how to do that. So here is the folder structure. Uh, so when you get access to the test suite, you will end up getting a zip file, which is a package for the test suite. Now this zip file will contain, as you can see, there are 11 folders on the root in the package. 10 of them are for the test suite, one for each. So 10 folders, say for example, MSOXC fold contains test suite for the OXC fold protocol. And there is a common folder which contains content which is common to all 10 test suites. So we'll go through one by one each file, what's the significance of each file. So the first one there in the configuration folder is the file name exchange common configuration.deployment.ptfconfig. This is the file that's it's an XML configuration file which contains detail about your environment. So there are some common settings that if you set in this file, all 10 test suites will automatically pick up the value from this config file. So common settings are stored here. Then we have a docs folder which contains documentation which is common to 10 test suites. Information like how to set up Exchange or what are the prerequisites and how to set up the environment. Those information is in the documentation folder. Then we have scripts folder which contains configuration script in order to configure both client and server. So script folder contains two child folders. SUT contains scripts which are required for the server side, and client folder contains script which needs to be run on the client side. The SUT folder contains two scripts. One which is named exchange SUT configuration.bat needs to be run on the server. Now some of our test suite require two servers to be there, one being a normal exchange server and another working as a replication server, where we create the ghosted folder because some of the protocol contains scenario for that. So if you have two servers in your environment, then second batch file is what you will need to run on the second SUT in order to do the configuration. But if you don't have second SUT, then you don't need to run it, and we will skip some test cases because you don't have ghosted folder configured. The script in the client folder needs to be run obviously on the client side in order to do configuration. There are some other PS1 PowerShell scripts. You can ignore them because batch file basically calls them when you run them. So they are just supporting scripts. Now, over here I've collapsed the common folder and expanded one of the test suite folder just to show you what's in the test suite folder. Over here we are seeing the OXC store test suite folder. So from the previous engagement with our customers, we have seen that customers want to run this test suite from the command line without opening even Visual Studio because they want to hook this into their automation environment. So this time we are releasing the batch scripts in order to run the test suite or test cases from the command line itself. So without even opening the Visual Studio, it will just go ahead and run all the test cases from the command line. So this batch folder contains scripts related to doing that. Then docs folder contains documentation related to a particular test suite. The first one of it is the PDF file itself, which is the open specification itself. If you want, you can go ahead and download this from MSDN as well, but we have just included in the package so that you don't have to do that. The next one is the Excel sheet. This is, as I said, we are extracting requirements from the technical documentation, and we are verifying basically those requirements when we run the test cases. This Excel file contains list of all the requirements for a particular test suite, for a particular protocol that we extracted from the open specification. So if you open this, you'll see all the requirements that we verify when we run the test suite. The next one is the chum file, which is a help file for the SUT control adapter. You'll see this chum file only if a test suite is using the SUT control adapter. If it is not, then it won't exist. If you open this chum file, then you'll see all the details related to SUT control adapter interface, and you'll find all the information that you'll need if you are implementing your own SUT control adapter. The next is the test suite specification. This is a very important document if you want to understand the test suite. This document contains information about what all test cases this particular test suite has, and what are detailed steps that each test case takes in order to when it runs. So go through this document if you want to understand in detail. And there is a source folder which obviously contains the source code for the test suite. The important file here is the SLN file, because it's the Visual Studio solution file which you open. If you open it, then Visual Studio will load the test suite and show you the source code for the entire test suite. So next is again, as I said, there are some test suite which are using the model-based testing approach. So I've expanded one example of a test suite which is using the model-based testing, and OXC FXICS is one of them. So in the model-based testing test suite, you'll see an extra folder in the source folder, which is the model folder. You'll see this folder only if the test suite is implemented as a model-based testing. If it is not, then model folder will not exist. Basically, this folder contains source code as well as model definition. So there is a file called .code. This file can be opened in Spec Explorer. It's basically a model design file. So if you open it, you'll be able to see how the model is designed and what are the details about the model. Also, there are some source code for the model, which is in the C# file there. By the way, there is a separate talk on model-based testing, I think on Wednesday. So I would encourage you to go through that one if you want to understand in more detail how model-based testing works. Okay, so now that you know the folder structure about the package, let's go ahead and see how to install and configure both client and server. So first I'll take the server, how to do installation on the server. So server installation for the test suites is very simple. It's an Xcopy deployment. Basically, all you do is expand the zip file and copy the common folder anywhere on your server. That's all you need to do. We don't need the test suite folder on the server, so you can skip that one. Just copy the common folder, and your installation is done on the server. In order to do configuration on the server, you run the exchange SUT configuration.bat, which is a script which will do all the configuration that server requires. So basically, this script is a kind of silent script. If you run it, it won't ask you any question. It will just go ahead and do all the configuration that that is required on the server. Things like it creates user mailboxes that test suite requires. It installs RPC over HTTP component on the server. It creates public folder database. It mounts it on the server, and then also creates some public folders. This script also provides manual steps in case if you don't want to do go do the things automatically by using the script. You can also use those manual steps provided by the script in order to do the configuration. We'll see that in the demo. So now let's see how to do installation on the client side. Client side, you will need all the files that's in the package. So just extract entire zip file onto the client. In order to do the configuration, we just need to run a batch file on the client, exchange client configuration.bat. This script is somewhat different because it will ask you questions about your environment. Things like what's the name of the server, or what's the password to the currently logged on user. and all those questions will be asked to you. Whatever responses you provide to the script, it will be set appropriately in the different configuration files. So you don't have to go and modify the configuration file yourself. That's the reason we created these scripts. This script also provides manual steps to you. So in case if you want to do your own configuration, or if you want to write your own script, you can do that. So now that we know how to do configuration on both client and server, we'll see how to run the test suite. There are two ways to run the test suite, one using the Visual Studio and one from the command line. This is how you run it from the Visual Studio. We'll also see that in the demo, but I just wanted to show in the slide as well. You open the Visual Studio Test Suite solution, which will load entire project. On the right side, you'll see a solution explorer where there will be a file ending with vsmdi. That's basically a list of all the test cases in a particular test suite. So if you double click on that file on the left pane, you'll see all the test cases loaded. From there, you can select any number of test cases that you want to run. There is no dependency between each test case, so you can select them in any order and in any amount. Once you have test cases selected, you can just right click on any of them and either run check test cases or debug check test cases that will basically run them. Now, how to run the test cases or test suite using the command line. So as I said, we have a batch folder which contains batch script in order to run the test cases from the command line. If you want to run all the test cases in a particular test suite, then there are special batch file starting with run all. If you run all Exchange 2010 test cases, it will run all the test cases which can be run on Exchange 2010. And if you run 2007, it will be running all the test cases which are for Exchange 2007. If you want to run specific test case from the command line, we also have separate batch files for running a particular test case. So, so in the example, in the screenshot below, if you want to run just the second test case, there is a separate batch file for that, so you can even do that. There is only one line of code in each of these batch files. So if you want, you can even generate customized list of BVT and create scripts to run them from the command prompt. So next, I'll go into detail about how to analyze the test results. There is a separate talk on how to do debugging on our test suite. So I think it's on Wednesday as well. So I would encourage you to attend that one in order to see how to do debugging in the test suite. But over here, I'll cover what all log files are available after you run the test suite and how to analyze them. So here is the list of all the log files which are available after you run the test case or test suite. The first one of it is a TRX log. This is a Visual Studio log that's generated by Visual Studio. It contains information about what all test cases were run, how many of them passed, how many of them failed, if it failed, where it failed, and the location to the source file. We'll see details about that later. The next one is the XML log. This is written by the PTF, Protocol Test Framework. Actually, our test suite source code contains calls to PTF in order to write entries to this log, XML log. And it will be a very detailed log containing all the information about even debugging information, requirement verification information. All those information will be included in that one. We'll see more information about it later. Sorry. The next one is the HTML report. Using the XML log that PTF generates, we also generate an HTML report which gives you information about the requirement coverage. So in this report, you'll find information about how many requirements were successfully verified, how many of them could not be verified, and list of all the requirements as well. If you wish, you could use Network Monitor to generate the capture when test suite is running. So it will capture all the traffic between client and server, and then later use it to analyze the traffic. If you do that, then you'll end up getting a cap file, which is a network monitor capture file. So we have a tool called RPX. You can use that tool to convert the network monitor capture file and do the parsing of, the tool will do the parsing of RPC calls and give you in a human readable format in a text file. There is a separate talk on RPX as well, I think tomorrow, so where we'll talk more about RPX tool. So this is an example of a TRX file. If you double click on TRX, it will load Visual Studio. On the bottom pane, you'll see all the list of all the test cases. And if any of them fail, you'll see the failed test case as well. If you double click on any of the test case on the top pane, you'll see detail about that particular test case. Over here in the first highlighted box, as you can see, the log will actually tell you what's the expected value for a particular call and what's the actual value. So this will be very handy to you if you find some test cases failing, then this will provide you enough information about why it failed, what's the expected value out of a call, and what it actually got. The second highlighted box also shows you the source code line where the call actually failed with the line number. So probably next time you can put a breakpoint and then debug the test case to see where it actually failed. This is an example of XML log. There are multiple kinds of entries in the XML log that we push. Things like debug entries, check succeeded entries, and checkpoint entries. There are many more entries in the XML log. So debug entries are basically debugging information. We write them in the test suite source code that whatever information is related is helpful for debugging. We just note it down in the source code, and they will be outputted when you see the XML log. Succeeded entries for any assertion which passed. So check succeeded is for that. There are checkpoint entries whenever we do requirement verification, and if requirement passed successfully, we will add a checkpoint entry in the XML log. Now, good thing about this is it is very easy to modify the XML log, like what all information should go in the XML log. There are just few entries in the PTF config file which decides what goes in the XML log and what doesn't. So say for example, if you don't want to see check succeeded entries in the XML log, you just remove one line from the PTF config, and even though source code has a call to add that entry, it won't be added just because PTF config doesn't have entry for it. So this is a screenshot of HTML report. We generate this using the XML log itself. This gives you information about how many requirements were there in total, how many of them could be verified, and how many could not be. There is a hyperlink on the numbers. If you click on that, you'll see list of all the requirements which were verified, which could not be verified, all that information. Now say you used network monitor to do the capture when test suite was running, you'll end up with a cap file. Now as I said, you can use RPX tool to convert that capture file to a text file which contains past information about all the RPCs, and I'll just refer to another separate session on RPX tool where we'll go in detail how RPX works and how to use it. But it is a public tool. You can go ahead and download it from the download center. All right, so let's dig into the demo. Okay, where's my mouse? All right, so I have two machines over here. They are plain operating system plus Exchange Server 2010 on the server side and Visual Studio on the client side. I haven't installed Test Suite yet, so I'll just do that right now during the demo. So I'm on the server right now. Is it visible? Should I do zooming? So I'm on the server side. when you get a package, uh, the package will be a zip file which will contain 11 folders. On the server side, all we need is the common folder. So I'll just go to uh, C drive, create a folder, paste the common folder. That's all I need. I will go to scripts folder, which contains SUT folder, and just run the script. So this is the script that does the configuration on the server side. As you can see, it's already started, and here are the manual steps that I was talking about. Saying whatever it does automatically, it also prints out the manual steps. So in case if you want to do that manually, you can do that. So over here, it's basically installing RPC over HTTP component on the server. It will have to restart the IIS process a couple of times in order to install it successfully from the script. It may take some time, like 30 seconds or so. Okay, so okay, so now RPC over HTTP component is already installed. Now script is actually creating some mailboxes which test suite uses. So all those mailboxes, public folders, everything will be created automatically, and it basically prepares your server to run the test suite. And for all the steps, you also have the manual steps written in yellow. So, so now script is finished. In case if there was any error in the environment while doing the configuration, you'll see them highlighted in the red. So keep a watch for that. I have the script has finished executing on the server side. So I have the environment ready on the server in order to run the test suite. I'll go to the client. On client also I have a package. I'll just copy all the files. Put all the files, extract them onto C drive. Okay. So it's copying all the source code, documentation, everything that's there in the package. So after the copy finishes, we will have to run a script in the common folder. So I go to common, scripts, client folder, which contains a script that I need to run on the client in order to do the configuration. I'll run it once the copy finishes. I just wanted to give you a feel of how easy the test suite installation is. So that's why I'm doing it from scratch. I could have like done it earlier as well, but okay. So the copy is finished. So I'll just run the script now. Now, as I said, this script is somewhat interactive. It will ask you some questions about your environment. Say, for example, the first question is enter the name of the SUT. I know that the name of the SUT is EXCH SUT303. So I'll just give that name over here in the script. It's asking me if the second server exists. As I said, some test suite requires second server, which is a redirection server, which contains a ghosted folder. In this case, I don't have second server, so I'll just hit enter. It has already detected which domain this machine is connected to, so it will automatically set that value in the configuration file. It's already detected my username. It's asking me for my password. This is the same password that all your offices, all the virtual machine in your offices also has the same password. So I'll give the password. It's asking me if the Exchange server version is 2010. So I'll just give yes because I know that Exchange Server 2010 is installed over here. It's asking me this machine has two IP address. Which one is reachable from the server machine? I know that 192.168.1.42 is reachable from the server, so I'll give that one. Now it's going ahead and querying some ESSDN for some users because it has to set that in the configuration file, so it's automatically doing that. Then it's asking me a question, what kind of encryption do I want to use? If I want to enable encryption, so basically the test suite support all different kinds of encryption authentication modes. So whatever value I set here, all test suite will automatically use that kind of encryption and that kind of authentication. So for now, I'll just go ahead and do 2 over here, which means that I want to disable the encryption. Here we have also mentioned what each, I'll just zoom it so you can read it. So what each value means, and we also have reference to the documentation, MSRPC section 22118, which contains more information about this values. Now, as I've given the value as 2, it's asking me to actually go ahead and disable, make sure that encryption is disabled on the server side as well. It's asking me to run this command on the server in order to disable the encryption. I've already done that. So next question is about the authentication mode. Test Suite supports this 3 authentication, then Spinego or Negotiate, NTLM, and Kerberos. Whatever value I set here, Test Suites will be using that as a authentication mode. For now, I can use say NTLM. So the value for that is 10. I enter 10 and hit enter. It's asking me what's the transport that I want to use. Test Suite support 3 transports, RPC over HTTP, RPC over TCP, and RPC over HTTPS. So here are the values that I could set. For now, I'll just set NCACN. Oops. Okay, I'll have to go ahead and modify that value in the config. I mistyped it. So after after giving reply to all the questions, it's actually going ahead and doing the setting those properties in the config file. Over here you can see what config file is getting modified, what's the value that's being set in the config, and all those information. Okay, so I have the configuration done. Only one thing I have to go and change the property because I mistyped something. So here is where the answer to all the questions are set. Over here, oops. So over here, here is where we set the protocol sequence parameter, and I've modified the value from NCACN to NCACN underscore HTTP, which basically means we are using RPC over HTTP. So now that I have the configuration done both for client and server, I will go ahead and pick one test suite, choose some test cases, and go ahead and run those test cases. I'll pick a very simple one, which is OXC MSG. I'm opening an SLN file, which is the Visual Studio project file. It will load Visual Studio with the test suite project and show me all the source code, configuration file, everything. Okay, so here is the solution loaded. I'll have to, of course, do the build, generate binaries for the test suite. Here is the VSMDI file, which is the list of all the test cases. If I double click on it, I'll see list of test cases available in this test suite. Okay, so here are the list of test cases. As I said previously, all our test cases are grouped into scenarios. So from the name of the test case, you should be able to figure out what scenario does it fall in. Now, if you want to get more information about test case or scenario, test suite specification is the document that you may want to go and read. Over here, I just want to run all the test cases, so I'll just select all of them and right click on them and select run. This will actually go ahead and create message requests to the server, parse the response which is sent back from the server, make sure that everything is according to the protocol, and give the result to me over here in the bottom pane. As we can see, all the test cases passed. This is the test suite which takes very little time to run. There are some test cases which require as much as 30 minutes to run, all the test cases. So it depends from test suite to test suite. Now, I will show you more, like I'll give you more information about the project solution project structure, but I want to show you some few things over here. This is the common configuration file that I showed you, that I just modified from Notepad. This is the config file which contains settings which are common to all 10 test suites. Things like name of the server. I'll do a zoom. Name of the server, or things like what's the encryption mode, or what's the authentication service, or what's the transport that's being used. All those information are written in this common config file, which exists in the common folder. But we have added a link to that file over here in each and every test suite solution, so that you don't have to go and navigate through the folder structure. So you can just double click on this over here and modify the value. Now, just understand that if you modify the value over here, all 10 test suites will pick up that value and use that when you run them next. There are also some other config files. The config files are named PTF config in the test suite because they are from the PTF. So, I'll show you. So there are some other config file as well. These config file, both of them are related to the test suite itself. So settings specific to this particular test suite are stored in this 2PTF config file, and settings which are common to all 10 test suites are stored in this common configuration PTF config file. So yeah, that's all I have in the demo. Any questions so far? Okay, good. All right, let me go back to the slides. Okay, so now that we have seen how test suite works, a very high level overview, I'll just go a little bit deep into the implementation details. Over here, you'll find this is a somewhat advanced topic, and if you are going to modify the test suites to run them against your own server-side implementation, you'll find this information helpful because you'll need to do some modification to the test suite. So here is the test suite project hierarchy. I just want to go through entire project and show you what's the significance of all the file in the project. This is, we have already covered, this is the VSMDI file, list of all the test cases. This is the test settings files. This contains this is a Visual Studio file basically, and this holds settings related to deployment, things like where your project gets built and how it runs and all those things. You don't need to modify it in most cases. This is the project which contains adapter source code. So this particular example is from the OXC RPC test suite, and this project contains source code for the adapter. Now, as I mentioned earlier, SUT control adapter is our implementation of SUT control adapter is done in PowerShell. So this folder contains PowerShell scripts, which are basically our implementation of SUT adapter. This is the interface for the protocol adapter. The next one, this is the interface for the SUT control adapter. So over here in this files which starts with I, you will see definition about the interface methods. There is no implementation in these files. It's just the definition. Implementation exists for the protocol adapter in this file, which is the implementation file of all the protocol adapter methods. This is a C++ library, which is a native native C++ code, which is RPC stuffed in order to do base Windows calls to RPC. So all the plumbing is done in this DLL. This is basically the project that actually contains the source code for the test suite itself. This is the file that contains some of the test case source code. We already saw this. This is the common PTF config file, which contains settings about encryption, authentication, name of the server, things like that. These are the PTF config files which hold setting related to a particular test suite. And this is also a PTF config file. Names are almost similar. The one contains deployment word in it, and another one doesn't. This one, which doesn't, it contains setting related to adapters and logging options. So if you want to change what goes in the XML log, this is the file that you'll make modifications in. Or if you want to have your own adapter implementation, this is the file that you'll have to modify in order to tell PTF where your adapter implementation is. This is again a file which contains source code for some of the test cases. So here I talk about major components of the test suites. Test suite is a combination of test cases, right? Now each test case drives some test steps, and the goal of each test case is to verify some requirements. And these requirements we have extracted from the open specification itself. Now there are multiple approaches how test suite can be designed. One of it is traditional test cases, traditional test suite, where we generate the source code by hand. Somebody will actually go and write the source code for a particular test case or test suite. Another is the MBT approach, model-based testing, where we generate a model of the test environment and then use tools like Spec Explorer we ask the tool to generate all the test cases for a particular model, and the tool will actually generate the source code. So we actually don't go and write source code for each and every test case. We just write the model, we ask Spec Explorer to generate the source code for the test case, and it goes ahead and generate the source code. So we have some of the test suites that we have are designed using MBT, and some of them are traditional. So we'll see that later. Okay. The next component of a test suite that all our test suite will have is protocol adapter. The task of protocol adapter is basically to create and maintain connection with the server, and also generate and consume protocol messages. This protocol adapter is basically responsible for formation of the particular protocol's messages, and it will also understand the responses from back from the server. The next one is SUT control adapter. SUT control adapter is used to control the server when we are running the test cases. So not all test suite uses the SUT control adapter. Here's the list of test suite that use SUT control adapter. There are only 4 out of 10. So other 6 do not use SUT control adapter because they don't have to interact with server. apart from the protocol that's being tested. So we don't have SUT control adapter there. But SUT control adapter can be implemented in one of these three ways, using the PowerShell. Another is using just by writing the C# code to implement the SUT control adapter. And the next is interactive adapter. This is very interesting. We'll see more about it later. So let's dig deeper into what is SUT control adapter. So when the test case has to interact with this with the server outside of the protocol that's currently being tested via implementation specific details, we have to use we basically use SUT control adapter. An example of that would be, say for example, we are testing MS-OXO rule, which is basically protocol for creating the rules. Now our focus is testing whether rules work or not, but in order to activate the rule, we may need to send an email, because when email is received in the mailbox, the rule may get activated. So sending an email is a task which is not on the focus right now, because we are testing actually the rules. So sending an email in this case would be put in the SUT control adapter. So the way we will do it is we'll write a PowerShell script to send an email and use a SUT control adapter to actually send an email, and that will invoke the rule, and then we'll make sure that the rule is actually doing what it is supposed to do, and make sure that responses are correct according to the protocol. Another example is when we are testing OXC store, which is about the storage. We have to create or delete the mailbox. So this is also done using the SUT control adapter, because that's not our focus. Our focus is on whether the storage operations are happening properly or not. So as I said, SUT control adapter can be implemented in one of three ways: PowerShell, using the PowerShell, using the managed code, or using the interactive adapter. If you are doing the PowerShell adapter, the way it works is you basically write PowerShell script for which the name of the script is same as the interface method. We'll see more later. But whenever interface method is called, PTF will automatically call your PowerShell script, and that's how it will work. If you have managed code adapter, it's very simple. You just write C# or VB.NET code for it and implement the adapter. If you have interactive adapter, this is interesting because you are not writing any source code for implementing this interactive adapter. The way it works is whenever you set in the PTF config that you want to use interactive adapter, you will get, whenever interface methods are called from the test suite, you get a dialog box saying do this on the server, go do this manually, and then come back with the result. So you are not implementing that by code or something. You are actually manually going and doing the operation on the server and then reporting the results back. So this is the quickest way to test, use the test suite against your implementation without doing much code change. So, but it's not, like using interactive adapter in an automated way is not possible because there needs to be some human intervention. Good thing about SUT adapters is they can be switched between different modes very easily. It's just a PTF config entry. You just go ahead and modify that, and that will change the behavior of the SUT adapter. We'll see how to do that. So here is an example of SUT adapter using PowerShell. So this is just an interface. The interface name, I've taken this from the OXO rule test suite, which is one of those 10 test suite that we have in the package. The name of the interface method is send mail to recipient, and we are doing in this example, we are doing the implementation using the PowerShell. Here is the corresponding PTF config entry. So in the PTF config file, there will be an entry which will mention that this is an adapter. The implementation is done in PowerShell, and name of the adapter should be same as the name of the interface, which declares the methods. And there is an attribute script dir, which tells PTF where your PowerShell implementation scripts are placed, which is the current folder in this case. And this is the implementation where I have written uh, the where I've implemented the SUT interface method in the PowerShell. The only caveat here is that the name of the PowerShell script should be same as name of the interface method. So that's how PTF will know that whenever a method in the PTF, a method in the interface is called, uh, that's the script to invoke, because the name of them, both their names are same. So my PowerShell script will be invoked by PTF, and interface method is called from the test suite code. This is an example of interactive mode adapter. So again, there will be an entry in the PTF config mentioning that this adapter is using an interactive mode. So instead of using, so in the last slide, you can see that the adapter type is PowerShell. Instead of that, I just go ahead and modify the same adapter using interactive instead of PowerShell, and I removed an attribute script dir because it doesn't make sense to use scripts attribute there. But just by making that one line, one change in the line, it will start using interactive mode adapter. Now, after setting that, if whenever the SUT control adapter interface method is called, I will be presented with a dialog which is similar to this one. It's basically asking me to send an email from a particular user to a particular user, and then once that is done, come back to this dialog and click on succeed. So I'm going to do manually go ahead and send an email and then click on succeed. So this way I don't have to write immediate implementation of the SUT control adapter myself, and I can still use the test suite to do testing against my own server-side implementation. This is an example of protocol adapter. As I said, protocol adapter is, you won't need to modify it in most cases. So this is just an example how protocol adapter is done. There is an interface which defines all the methods. There is respective implementation of all those methods. So it's all C# code. And there is, for protocol adapters as well, there are some entries in the PTF config which says that this is the protocol adapter. It's implemented in the managed way, which is C# code. And the type of the adapter is the fully qualified name of the class which does the implementation. So so that will tell PTF which class contains the implementation. It uses reflection to call those methods and execute the code in the protocol adapter. So here is again reiteration of different test approaches. It can be traditional, where we write the source code by hand. It can be model-based testing, where we use tools like Spec Explorer to generate the source code depending on the model. And it could be hybrid, where we use both traditional and model-based testing. Out of the 10 test suite that we have in the package, these are the 6 which uses traditional approach. That means we have written source code for all the test cases in this test suites. Okay, sorry, 7 test suites are traditional and 3 test suites are model-based testing. So you'll find code file in this 3 folder, which is the model definition. All right, so next section is about testing at the event. So as I said, all your offices are configured to have virtual machines, which like there is one client virtual machine and server virtual machine. You'll be able to use these test suites, install them, configure them, and run them over here. This is again the list of all the protocols that we have available for testing. This is just environment definition for your offices. Each office contains 3 to 4 physical boxes. There are 2 virtual machines for each environment, a client and server. Server already contains the Active Directory, which does the authentication. These virtual machines do not contain test suite installation, so we want you to do the installation yourself over here at the event. So if you have any question, we can help you. So they are just plain base operating system images with Exchange, of course, installed, and with Visual Studio installed on the client side. If you are man in the middle, if you are developing some device or appliance that stays in between client and server, it is possible to do that in this environment. You'll be able to plug your own devices between client and server and go, like, analyze all the traffic and maybe do the optimization as well. If you are interested in doing in testing against Exchange 2007, that is also possible. Just get in touch with us. We'll tell you how to do that. There are basically another set of virtual machine. There is another environment configured to do Exchange 2007 execution. Availability for the man in the middle as well. All right. Throughout entire week, you have time to do the testing. Our test suite team is ready to help you guys. The test suite team contains myself, TK, Pui, Yong, and Steve. So just get in touch with us if you have any question or if you have any doubts. Um, After the event, if you want access to all these test suites after the event, if you want to configure them in your own environment at your offices, just send Michael your live ID, and we'll send you an invite to download this package. Just remember, this is in the beta 2 phase right now, so it's not a final build. You may see some bugs, some issues. We would be glad to hear them and fix them before going to the public release. And also we have the support available for this test suite. So if you have any question, dochelp@microsoft.com is the email address where you'll get support about this test suites. And next is Q&A. If you have any questions, doubts, queries. Nope. All right, great.